Hello, class, and welcome to arithmetic time. I'm excited about today's lesson, all about geometry. Do I have that word right? Geometry. If you look up here at the chart, we're going to review some of this first, and then we're going to be going into some geometry on your paper for today. So let's first review what we've talked about before. Remember those measurement problems we did yesterday? Go back to April, let's see if this is for April 23rd, go back to April 22nd lesson and go through those and learn those if you had any problems with them. We're going to start here. These are some that often get forgotten. All right, so 1 gallon equals 4 quarts. I think you do know that one. 1 quart equals 2 pints. 1 quart equals 2 pints. So twice as many pints as quarts. Here's the one, 4 pecks in a bushel. 4 pecks in a bushel. Think of just like there's 4 quarts in a gallon, 4 pecks in a bushel. So quarts are to gallon as pecks are to a bushel. Okay, you can know that one. For a bushel, think of the 4 big pecks. Its volume, it's like baskets of things, big baskets, okay? And whereas quarts are usually liquid, although not always, because strawberries, and you can have a quart of strawberries maybe in a peck. So you can see these are actually smallest. They make a peck, and then a peck makes a bushel. So all of these quarts makes 1 peck, and these 4 pecks make a bushel. So a bushel is very large, very large. And look, think of 1, 2, 3, 4, 5, 6, 7, 8. 8 quarts in a peck. Memorize 8 quarts in a peck. That is one that's often forgotten. So how many quarts would be in a bushel? That would be the question. If there's 8 in one of these, that'd be 32, wouldn't it? Because there's 4 in a bushel. So a lot of quarts in a bushel. Now let's go over here and say them together. Ready? 1 gallon equals 4 quarts. 1 quart equals 2 pints. 1 pint equals 2 cups. 1 cup equals 8 fluid ounces. 1 pint equals 16 fluid ounces. And then we have a gallon equals 4 quarts, which equals 8 pints, which equals 16 cups, which equals 128 fluid ounces. So a gallon jug has 128 ounces, and that's one it'd be good just to memorize, although not required at this point. Remember yesterday, 1 tablespoon equals 3 teaspoons. Look, here's can you see that all right? There's the tablespoon, and then there's the teaspoons, and you can see the tablespoon is larger, and it takes 3 of them, and we proved that yesterday. So the next time you're making something in the kitchen, if you ever do that, or if you do it with your parents, you can play around with that. Do that. Now, behind these charts, right behind, I'm just going to set them on the floor. Some Roman numerals. Let's see if we can remember our Roman numerals and not forget them. M equals what? That's right, 1,000. 1,000. That what you said, Colin? 1,000 what? Colin's going to tell us, right? If you say there's 3 of them and there are 300, 1,300, 2 x's is 20, and then 4. Put my comma. Who got that one right? Raise your hand, nice and high. 1,000, then there's 300, and then 10, 20, and then 4. 1 in front of these 4 because we subtract. A lesser numeral precedes a larger numeral, we subtract like that. All right, let's do the next one. M means 1,000, so 1,000, 2,000, 3,000, what? V is 5, and 1 6. 3006. We got to put a 0 there. Look at how I wrote that. 3006. Is the red showing up all right on there? 3000 and then 6. Notice it's 3006 for your answer. Okay? So make sure there's a placeholder. You can't just put 3000 and put a 6. You have to put zeros for the place value. Ones, tens, hundreds, thousands. There have to be 4 places there. All right, so then we're going to go to this one. We have that's 10 and that's 50, right? 10, 50, so we have to subtract 10 from 50, which would give us 40. Subtract 1 from 5, 4. So 40, what? Yes, 44. How about this one? L is 50, 5, 56, 57, 58. Who got that one right? 58. Who said 58? You said 58 at home? You are right. We add 5 to our 50. We add 8 to 50 because V and the 3 is 8, right? 58. Okay? And so that's just a little bit of review for us, and then we're going to get into our lesson time. So here's what I want you to do for the rest of the time. It won't be a long video today. What I want you to do is I want you to grab your book if you don't have your book, and I want you to come back here, come back, and meet me back here in just a minute, and we will go over the geometry, which is the new part. I want to go over a few things with you in just a moment. So here we are, and I'm looking at your book and our book, and if you look at Introduction to Geometry, you see some basic shapes here, don't you? You see some geometry terms as well. You see a point. It's just a dot. Now we know a decimal point, so we're familiar with that. A line segment. Line segment is a piece of a line. So, and there's 2 dots on the end. So I want you to memorize these. You could even make your own cards and be able to write these in the blanks. A line has an arrow on each, well, it is an arrow with a double-sided arrow. It's a line. It's got to have the line, or if it has dots, it's line segment. A ray is where there's a point on one end and the arrow on the other end, and that's what we call the ray. An angle is 2 rays. Let me show you what I did here on my paper. Here's a ray with the dot and an arrow on the end. 2 rays equals an angle. We put the 2 together and we do that. And we can have angles, different angles can be different sizes and different degrees of angles. Okay. A right angle is, let's look over here. 2 rays that have a common endpoint, we said were angles, right? A right angle, angles with a square corner. So for example, I could take this, this is just a memo pad, see? Post-it notepad. And I could actually, it's got a right angle. It's a right angle because it's a perfectly squared corner. You see what I'm saying here? So I could take this here and I could go like that, and I could move away. This we would call a right angle, where it goes straight out and straight down, or straight up and straight across, however you want to think about it. And we call that a right angle. And here's an example of one right there. And you see that little box? You always know if it's a right angle because there'll be a box. That means it's perfectly 90 degrees, by the way. They have a perfect squared corner, and it's a 90-degree angle. So know that that's a right angle. Congruent angles, they are 2 angles that are the same. They're the same degree. So for example, I could draw an angle like that, and I could draw it, but they're not the same, are they? This is a bigger, wider angle than that is. You see what I mean? So they're not congruent, whereas those are the same. So those are congruent. Intersecting lines are lines that cross. They intersect. Just like an intersection where you have a stoplight. They cross. Those are roads that cross. These are lines that cross. So there's the line with the arrows, but there's two that cross. They intersect. Perpendicular, it's a line, but then there's a line segment that's coming up from it. Or it could be going the other way, but it doesn't cross. If it crosses, it's intersecting. So be aware of that. It doesn't cross. And look, it's forming two right angles. See that? That's a right angle. That's a right angle. Now it could go down the other way. You could have a line and you could have a perpendicular going that way, right? And then it would form a right angle here. Whoops, book's moving, sorry. And a right angle there. And there's a right angle here and a right angle there. Two right angles that it is making. And that we call perpendicular. And then parallel lines. I like parallel lines because they're just two lines running right along each other for as long as you want. Okay, so for as far as you want. So here's a line going this way, all the way. It could be going to infinity if you wanted it to. Here's another one. And they're both the same. Now, if at any time they intersect, like these are going parallel, but then they start crossing, they're no longer parallel. They're intersecting, aren't they? That's funny and odd, isn't it? That would be like that. But those aren't true parallel, are they? Because they cross. But those are parallel because they do not cross. So on your paper today, you will be reviewing the things that you normally do, that you already know how to do, but this is what's new, the geometry. And then you can go on to the story problems. So you'll do these, you'll answer questions about geometry on the first page. Now go to your story problems and look there for a minute. And then I'll let you loose to do your paper, all right? 4A, what part of an hour? If you look at story problem 4A, it's going to ask you what part. What do we mean by what part? That could be another clue word we could add. What part means we could also be saying what fraction, couldn't we? It's going to be referring to a fraction or decimal, but mostly fraction if you say what part. A part of a whole is a fraction, right? What fraction of an hour? What part of an hour? Well, from 3:30 to 4:15. The 30 is on the 6, right? 30 past, up to 4, and then to the 3 to make 4:15, right? I mean, it's gone all the way up to the 12 and over to the 3, hasn't it? So how much of an hour is that? Well, guess what? Couldn't we do this like a fraction circle? Couldn't we go like that? What if this was our pie? How much of our pie have we eaten? Or how much time has gone by in this case? But we could look at it that way. What fraction, does that give you a clue? What fraction of the hour has been spent? Or we could do it this way. From 3:30 to 4 is 30 minutes, right? 30 minutes. And then from 12 to the 3 is 15 minutes. And we could go, how many minutes? Okay, that's our total minutes. We put that on the top of our fraction. We know how many total minutes are there in an hour? 60. And we could figure it out that way. There are two ways. This is kind of a visual way of thinking about it. this is an exact, and this will give you more an exact answer because ours came out nice and even this time, but it might be a little sliver. It might not always be easy this way, but it was this time. All right, so you figure out what fraction of it and reduce it. And it says what part, and then make sure you put the label at the end. This fraction of an hour will be your answer. Now let's go to story problem 4B. They played tennis for 1.5 hours. How many minutes did they play? So the first thing you need to do, it's asking us in minutes, so don't let that throw you. How many minutes? Well, 1 hour, we have 1 here. 1 hour is how many minutes? We know that 1 hour is 60 minutes. You knew that, right? And then half an hour is how many minutes is half an hour? How many minutes? Add them together and get a total. And then you'll write, I ran in a room on this little, I was just writing on a little Post-it note, but you'll get a total on your paper because you won't use a Post-it note, you'll use a piece of paper if you need for word problems. And then you'll make sure you put the word minutes, and abbreviate it, minutes, okay? They played this many minutes would be your answer. This many minutes, and you'd circle your answer. All right, so you do that, think about that, enjoy the geometry, enjoy the story problems, and look here. Here's something we did last year. It was kind of an art project. We took construction paper and cut them into different shapes of geometry. Octagons, triangles, trapezoids, all different triangles, different shapes, even circles at times, squares, rectangles, and we had different colored construction paper. And then we glued them to make the picture of maybe take yellow ones, different shapes, and or different colors to make the animal. We were making a bird when we did it. That might be something fun you could do if you're at home and wanting something interesting to do. Hey, if someone wants to do that and show me one, I would love to see it, and you could send what you made to me if you want, and that'd be something fun to do with geometry. But of course, the work comes first. So do that, enjoy it, and let me see. I want to say goodbye to you, so I'm going to go like this. Let me see my door. There we go. Until next time, I hope you've enjoyed our time here in math, and you be looking for the next video. All right, you take care. Miss you all.